Welcome to Lakshmi Education Center. Today we are discussing about the topic is magnetic effects of current. The work done in moving another charge around a charge plus q along the circumference of the given radius r is 0. Work done in moving a charged particle outside a hollow charged metallic sphere. Finite. When the distance between two charges is reduced n times, the force of interaction becomes n square. A capacitor can't be given an infinitely high charge because behind the electric limit of medium, the capacitor will discharge. Two charges Q1 exerts force F on another charge Q2 on bringing near a third charge Q3. The force F Q1 exerts on charge Q2 will not change, depends on interacting charges only. Two charged plates of a capacitor are moved apart. What will the ammeter show? Charge decreases. The electric field E due to two equal and opposite charges in vacuum will be parallel to the line joining the charges at any point along the line joining the two charges. The ratio of forces acting between two charges plus 2 and plus 4 microcoulombs is 1:1. And similar capacitors are connected first in parallel and charged to potential V. The potential difference across the n capacitors connected in series after separation will be nV volt. For a hollow charged sphere, potential due to field remains unchanged inside it. Two charges are placed apart. When a glass plate is between them, the force of interaction will decreases. Two metallic charges spheres with potential difference of one greater than the other are brought in contact with each other. The charge on each sphere move from sphere with higher potential E equals Q by R to sphere with lower potential until charges potential are equalized. As a unit charge moves from the surface to the center of a uniformly charged hollow sphere, the electric field intensity experienced by it is 0. The ratio of force of interaction between two charged small spheres in air and in a medium of dielectric medium is epsilon:1. The resistance of a combination of resistance in parallel is 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3 plus dash dash plus 1 by Rn. An electric charge moving with uniform velocity V produces both electric and magnetic fields. Why can or cannot metal be used as a dielectric medium is metal being a good conductor will short circuit the capacitor. Potential of electric field is a scalar quantity. Three resistance of 3, 5 and 2 ohms are connected in series. The total resistance of the combination 10 ohms. Ohm's law is applicable to conductors having a linear relationship between V and V by I equals R equals constant. Current flows through a conductor because of motion of free electrons in it. Kirchhoff's first law, that is at any junction between point Si equals 0, is based on law of conservation of charge. Kirchhoff's second law, that is in any circuit epsilon I r equals epsilon E, is based on law of conservation of energy. The current flow in a commuted circuit given by Kirchhoff's law. The charged spheres of different radii are connected by a thin wire. No current will flow it, each one has a potential. Two charges are placed apart. When a metal plate is placed between them, the force of interaction will increase. A transformer is not used with DC voltage because DC voltage is constant, thus flux is zero. The Ohm's law, even when dielectric is passed through a liquid, is true. The resistance R, ohms of a wire, when stretched to double of its original length, is twice its original. 2 R ohms value are a length by area. The work done in that case, when a coil is moved over a magnet rapidly, is more or when moved slowly, when moved rapidly. How is power related to voltage and current? P equals V by I. If R1 and R2 are resistance of the filament of a 200 watt and a 100 watt bulbs respectively, then R2 equals to R1. When the cross-section area of the conductor is doubled, the quantity of charge passing through a conductor is reduced to half. A cell of EMF E connected to a conductor of resistance R ohms gives a potential difference of V volts. Across terminals, the internal resistance of the cell is E minus V into R by V. A resistance R is connected to two cells with same EMF E volts and internal resistance R1 and R2 ohms. The potential difference across first is 0 volts. R is R1 minus R2. Thanks for watching. Like, share and subscribe.